I'll just get started. Thanks everybody for joining our webinar on CAN bus data logging. This is the second iteration of this webinar that we're doing. And the purpose is to give a very brief intro to CAN bus, then give a bit of context on how to record CAN bus data and how to decode it. And then we will also be introducing our CANedge data loggers and the software and API tools for these. You can see a bit of the agenda we're going to go through. I will try and cover this in 1 hour, so some of it will be a bit fast. For those of you wondering, this will be available on our YouTube channel afterwards, so you can always watch the video there. So as mentioned, we'll do a brief introduction, a bit of the basics on CAN logging, then go through our hardware, our software, and then Q&A at the end. If we start with CSS Electronics, we are a small company based in Denmark, started in 2015, and we specialize in developing and selling CAN bus hardware. Specifically, we do CAN bus data loggers and sensor to CAN modules. We also have quite a lot of online content, as some of you may know. We have very popular CAN bus articles on intros to things like CAN, CA1939, and OBD2. And we also have a lot of videos on our YouTube channel. Our products are today used by around 5,000 companies across 100+ countries, and most of our end users are engineers working at automotive or industrial OEMs. So you can see some examples here at the bottom of the screen. My name is Martin, and I'm one of the co-owners here at CSS Electronics. We are a privately held company, and my main responsibilities are in the area of sales and marketing. So that includes the online content such as articles and videos, but it's also technical sparring and support for the majority of our customers. That also means that I have quite wide experience with many different use cases within the area of recording CAN bus data. If we just get started with the basics here, what is CAN bus? Most of you who are here in this webinar most likely know, so I will not be covering every single bit of CAN bus, and you can find more details on this in our introductions. But in very basic terms, a CAN bus at the end of the day consists of a twisted wiring harness, as you can see on the left, a CAN high and a CAN low wire, and it is essentially a means of communicating information between ECUs. So that can be ECUs in a car or in a truck or some other CAN bus application where you need to send information from one part of a vehicle to another part of a vehicle, as an example. This information is packaged in what we call CAN bus frames. You can see a standard CAN bus frame here from classical CAN. And we have highlighted two parts of this, the identifier, which is 11-bit or 29-bit, and then the data. And the data is essentially where you will see the different information like speed and temperatures, pressure rates, and other things being packaged into raw payload data bytes. Today, CAN bus is extremely widely used. It is de facto the standard for most mobility things. That means anything with wheels, but also beyond. So it could be in maritime vessels, it can be in aerospace, it can be the Boston Dynamics Spot dog, and many other things. If you need to understand CAN bus, you will typically also need to have a basic understanding of some of the higher layer protocols. If you think of a CAN bus as a way of communicating, then you can think a bit of the protocols like the languages in which you can communicate. I have sort of highlighted 6 of them here. CA1939 is a very popular protocol which is used in heavy-duty vehicles. OBD2 is another popular protocol used in most non-electric cars today. You have isobus, which is very similar to CA1939, being used in agriculture applications like tractors and implements. Then you have UDS, which is a bit like OBD2, but more of an OEM diagnostics protocol, and also used increasingly in electric vehicles as well. Then you have EMEA 2000, which is a maritime protocol that is often used in ships and boats, but also sometimes used in agriculture vehicles, for example, for GPS information. And then you have something like CANopen, which is used frequently in industrial automation. So, for example, in production applications and the like. As you can probably see from this slide here, we have deep dive articles on all of these on our website. So you can go there if you're interested in diving into one of these. And there are more higher layer protocols beyond these. But it's mainly to give you the idea that you have the CAN bus being, you can say, the lower layer protocol. And then you have different protocols that have different implications for recording CAN bus data, depending on what type of use case you have. So let's jump into the main thing here. How do you actually log and how do you decode CAN bus data in practice? It's relatively simple. Let's imagine that you have a CAN bus data logger, and I'll get back to more details on this later. You take your CAN bus data logger, you find the suitable adapter cable, and then you just connect the device to the application you wish to record from. For example, a vehicle, as in this illustration over here. Depending on your use case, the adapter will differ, and this is a bit back to the higher layer protocols. For example, in a truck, you will often see what we call the J1939 adapter cable, the one that has a green connector up here. In Caterpillar vehicles, there is a very similar connector, but it's a bit different with a different pinout. In most cars, you will have seen the OBD2 connector below your steering wheel, and that is a way to access the CAN bus data of your car, or at least to make requests for data to your car. In some cases, you don't have a standardized adapter or a standardized connector that you can use, and here you will need to create your own custom wiring harness. And one way to get started with this is to use an open wire adapter cable, which we also provide. Then you have the M12 adapter, which is often used in maritime applications and in CAN open applications. And if all of these fail, then you always have the opportunity of using what we call a contactless CAN bus reader, which is essentially an adapter cable that allows you to read data by hooking it onto the CAN bus wiring harness directly. You're not cutting anything, so you're not breaching the warranty. And then through induction, you read the data from the CAN bus as a read-only methodology. So it seems simple enough to get started and to log some CAN bus data, but it sometimes goes wrong. And there can be many issues that might cause you to not record data, or at least not record the data that you expected to record. If we take some of the most common troubleshooting issues that we encounter, then we have divided them into a bit of categories here. In terms of the basics, one of the most common issues that I encounter is that a customer is using the wrong adapter cable. They purchased an OBD2 adapter cable from Amazon, and unfortunately, it did not have the correct pinout for use with our devices, at least. So it's always important to check that the way the wires inside your cable are wired matches both your connector in the vehicle or in the machine you're going to record from, but also the data logger or streaming interface that you're going to connect the adapter to. You can also have the situation that you are connecting everything correctly. It just so happens to be that no single node on the CAN bus is communicating any information onto the CAN bus. So everything is basically silent and therefore you're not recording anything. So always check your setup to ensure that you're actually broadcasting data as expected. Similarly, if you are a bit in a testing setup on your test bench, you might have forgotten to add termination properly. So you should have a 60 ohm resistance on your CAN bus, which typically equals 2 terminal resistors, one on each end of your CAN bus. So you may have forgotten this and you need to fix it, otherwise the communication will not work. Assuming all of that is in place, you can also risk that you configure your device incorrectly. A common issue is, again, in the test bench setup, you might be looking to record data from a single ECU or a single CAN node, as we call it. But there are no other devices on the CAN bus, and you may have configured your CAN logger to be in silent mode, which essentially means that it is invisible on the CAN bus. It does not even acknowledge messages from other nodes on the CAN bus. And in such a situation, the communication will in fact not work because a CAN bus requires that there is a sender and a receiver and that the receiver acknowledges the message on the CAN bus. Otherwise, the communication fails. This is simple to fix. You just need to ensure you're not using silent mode in that particular scenario. Another issue is if your bit rate is wrong, For many devices, this can be a bit of a pain. The CANedge is in fact quite good in this regard because it can auto-detect the bit rate, but for very specialized bit rates or for niche use cases, this might fail. And in such a case, you would need to set the bit rate manually. And if you set it incorrectly, and you, for example, set it to 500K and the CAN bus uses 250K, then it won't work. And finally, in the configuration area, you could also have set up filters on your CANedge. By default, most CAN loggers will record everything on the CAN bus, but you can typically also filter the data. And of course, if you have filtered the data in such a way that you are not getting the data you expect, then it might appear as if you're logging nothing, but in fact, you are recording something. It's just getting filtered away. When you get past these basics here, you might be in the field and you're trying to record from, let's say, a heavy duty mining vehicle. And you're doing everything right. The connector is right, the adapter cable is okay, your configuration is right, and you're just not getting any data. The same can occur if you're just recording from, let's say, a Volkswagen car, for example. You are connecting through the OBD2 connector and expecting to see something, and nothing happens. This is typically because there is what we call a gateway that is blocking or filtering the access to the CAN bus or to the, so you can say, the raw CAN bus data. In such a case, you will typically need to request the data you're interested in, for example, OBD2 or UDS, or you'll need to get around the gateway through, for example, a contactless CAN reader. If you are trying to request data from the CAN bus, you might be doing it wrong. So you might be sending some requests with the wrong CAN IDs, the wrong length of the CAN ID, or with the wrong protocol. And in such a case, you will not get any results. And even if you are sending valid requests according to the protocol, it might just be that the vehicle in question does not happen to support the particular request that you're trying to send. So that is also a risk that can occur. Finally, in the field, you can have multiple CAN buses. So we work with OEMs that are recording across 8 different CAN buses on the same mining truck. So obviously, if you are going to work with such a vehicle, you might, end up in a hit or miss situation. You are looking for data from a specific CAN bus, and you keep testing a new CAN bus whenever you find a new connector in the vehicle. And at some point, you might be lucky and get the right CAN bus you were looking for, but in 7 out of 8 times, you're not. And this can be very difficult if you're not the OEM or if you do not have technical expertise in this particular vehicle to determine what is the right access point for this particular CAN bus you're interested in. Now, when you actually get past all of this stuff here, you might actually be recording data. It might just be that it's not the data that you expected. So when you try to decode it, as we'll see in a bit, you're just getting nothing. And this is not necessarily because there's anything wrong with the data. It might just be that you were hoping that this particular CAN bus would have data in a specific format that could be decoded by whatever database you had, but that was not the case. And that can sometimes also be a situation you end up in. Now, let's assume we're past all that, and now you have successfully recorded some raw CAN bus data from a truck, for example. And let's look at the data on the left. What you see here is essentially a collection of time-stamped CAN identifiers and data bytes. And to most of you, this in itself will not make a lot of sense. It will not be very useful. And that is because you are not, Neo from the Matrix. You cannot make analysis based on the left-hand side here. You need to somehow decode this into sensible information, or what we call physical values, or human readable form data. And this is essentially what you see on the right-hand side. Here, the raw CAN frames have been decoded into physical values so that now you have timestamps again, but this time you have relevant signals like engine speed, engine hours, fuel level, speed, temperatures, etc. This is the process that we refer to as decoding the CAN bus data. And without this step, you won't be getting much information or insight out of your data. The way you decode data is a bit industry specific. So within the automotive and a big part of the industrial industry, something called DBC files are used. There are different formats other than DBC files, but this one is perhaps the most commonly used and the most commonly encountered when you are looking to decode CAN bus data. A DBC file is basically just a text file. You can see it here on the right-hand side, where it's been opened in Notepad, and it will tell you for the different CAN IDs or the different CAN messages, what are the signals, like engine speed, that are encoded within this particular message, and in which part of the message is this particular signal encoded. So you might have, 8 bytes in a CAN frame, and 2 of the bytes here comprise engine speed. And you need to decode it by basically converting it to decimal form, scaling it in a linear equation. Now, you don't do this manually by hand. That would be a very difficult exercise, but you will use software tools to do this, as we'll get back to a bit later here. So the DBC file is the key. It is the database that will take you from useless CAN bus information, which you can effectively get from any CAN bus application, and it will convert and decode this information into useful information in the form of decoded signals that you can visualize, that you can analyze, that you can perform statistical analysis of. Now, the problem here is that typically these DBC files are proprietary. That means the OEM, the original equipment manufacturer of the car, of the truck, of the robot dog, or whatever it might be, they have this DBC file and they don't want to share it. That's the most common situation. And why don't they want to share it? That is typically because it is considered sensitive information, and typically also because the OEM might have their own tools, their own scan tools, diagnostic tools, and the like, which they would like to sell essentially as a service or as a separate hardware tool along with their equipment. So they don't necessarily want these DBC files to float around in the market, because then essentially anybody could decode their data, which they might not want. It may be shared with partners. So if you are a big customer of, let's say, bus fleets, for example, you might be able to talk with the OEM and get the DBC file under an NDA. We see that sometimes. There are others that attempt to reverse engineer this. Some businesses essentially do this as their main competitive edge. And there are also private people doing this. So you find various reverse engineered DBC files on GitHub, but they vary in quality and they are not necessarily reliable. And then for some modules and some CAN bus applications, you will have the concept that the DBC file is part of the package. We at the CSS, for example, sell various modules that output sensor data through CAN bus. And of course, for that to be useful to our end customers, they need the DBC file, which we, of course, share free of charge together with the products. Now, luckily, for those of you that are not OEM engineers, you can still record data from many applications, such as heavy-duty vehicles, agricultural vehicles, maritime vessels, and many passenger cars. The reason for this is that, to some extent, some of these higher layer protocols we discussed previously are standardized. J1939 is standardized. That means that there is around 10,000 plus signals that are standard and which are encoded in a specific way. And the OEMs will often, when they put together a truck, so to speak, use this particular encoding for many of the signals. In practice, that means that if you have a standard J1939 DBC file, which we offer, then you can decode most of the data in most heavy-duty vehicles. Still, this requires testing case by case, but it gives you quite a good chance to get useful data across even mixed fleets of heavy-duty vehicles if you have such a DBC file. The same goes for boats and ships for the EMEA DBC file, and the same goes for cars for the OBD2 DBC file, with the added comment that for the OBD2 case, you get quite a smaller subset of signals at a lower resolution, which might suffice for some use cases, but for others, it might not be enough. And now we're talking about OBD2. This is an example of a bit more of an advanced use case in CAN bus data logging, where it is not enough to simply connect a CAN logger to your car, because if you do that, the CAN logger will just await information from the car. And as we discussed earlier, many of today's cars, they are not going to broadcast any data through the OBD2 connector. And if they did, that data would be proprietary, meaning it's useless to you unless you are the OEM. So if you are a private person, maybe you are a father that wants to monitor the driving behavior of your teenage sons, for example, what do? In this particular case, you can use the fact that the car most likely supports the OBD2 protocol to send requests into the car and say, dear car, I would like to get the speed value every 5 seconds. So you're basically sending a message, give me speed. And the car says, okay, here is the speed. And then 5 seconds later, you say again, hey, give me the speed. And the car responds with the speed. So you do this on a regular basis, and that gives you essentially communication in the form of CAN bus frames, but which you can decode because you have the OBD2 DBC file, because we provide that free of charge on our website. So in other words, for those type of use cases, all you have to do is configure your device accordingly. And obviously for our devices, and you'll see this across other devices as well, because OBD2 is such a popular protocol, we provide plug and play configuration files for that particular use case. A slightly more advanced use case is something called multiframe data. And I'm not going to cover this in detail, but more provide it as an example of things that get a bit more tricky within CAN bus data logging. So we just discussed the case of requesting data from your car. Let's say you had an electric car like the Kia EV6, which I have. In order to request data from that, you cannot use the OBD2 communication that is simpler and which we just discussed. But luckily, some people on GitHub have found out what do you do instead. And what you can do in this particular case is to use something called UDS, Unified Diagnostic Services. And it's very similar to OBD2. You send some request messages and the car responds back to you. However, it is a bit more tricky. When you send a request to the car through a multi-frame protocol specification like UDS, you send an initial request here, then the car responds with what is called a first frame. Once you receive that, you send a flow control frame, and then the car sends back multiple frames that contain the data. And the idea here is that this is a very efficient way of packing a lot of data because the car can essentially spam, let's say 20 frames in a row containing all sorts of data, meaning instead of being able to send one or two CAN signals, it can potentially send 20 CAN signals in one go. That puts a challenge on the software that you have because the software now needs to be able to work with all of these frames and do what we call reassembly, where you essentially pick them apart and restructure them into a combined or reassembled frame, which will have a payload that is perhaps 59 bytes instead of 8 bytes. And now you can try and decode this, assuming you have, again, the DBC file for this particular case. So if this is a topic you're interested in, check out our UDS intro on the website. So this was a bit of the basics on how you record CAN bus data. And as you can see from this illustration recap, it's a matter of getting the right adapter cable, getting a device for recording the data. That will give you some raw CAN bus data, potentially in log files. And if you have the DBC file associated with this data, then you can put these two components into a suitable software tool, and magic, you have plots. Now, to get a bit more practical on how this looks in real life, I'm going to present a bit about our products and how they do the different roles that you see in this overview here. So if we take the CANedge, then this is our primary product, which consists of a couple of variants that do more or less the same thing, but with a few variations, basically. We have the CANedge 1 for offline logging, the CANedge 2 for Wi-Fi transfer, and the CANedge 3 for cellular transfer. And I'm going to explain a bit about the features of these different products here. If we take the CANedge 1, first of all, you can see it here on the right-hand side. This device is effectively our way of designing a device that is both extremely easy to use, meaning that it should be so plug and play that anybody should be able to use it. That means when you take the device and you get it out of the box and you take an adapter cable that is suitable, connected to your CAN bus, then the device powers on and it will just start logging the data. It abstracts away many of the complexities, such as the bit rate, because it automatically does all of that for you. And if you disconnect the device, it is 100% power safe, so it will safely ensure that your data is stored, and you can take out the SD card and you can start reviewing what you recorded. So pretty simple. At the same time, we cater to a professional audience first and foremost. We specialize in OEMs, typically engineers, as well as system integrators. And both of these target audiences have quite strict requirements on what a device like this should be able to do. That involves, for example, being able to record any bus load on both of the CAN channels, whether that is 50 frames per second on a channel or 4,000 frames per second on a channel. That should be possible to record without any message loss, which is something the CANedge does. It has two CAN channels, two LIN channels, and it supports CANFD. It also supports error frame logging, and it timestamps the data at a 50 microsecond resolution. So in other words, you get a pretty hefty package that is comparable to many of the ProSpecs loggers on the market, but at a much lower price. And another thing that is different is that it is extremely small. So if some of you have been working with some of our German or Swedish competitors, and you are familiar with some of their CAN bus data loggers, then this is so much smaller. And you can see it from the illustration, but you really need to have one in your hand to get a feel for it. It weighs 0.1 kilos and it can fit anywhere, which means that you can deploy it on a bike or you can deploy it in a cabin in a car. You can essentially hide it away and it doesn't obstruct the driver. At the same time, we have added mounting flanges in our latest hardware revision to this, so it's very easy to mount the device in the field. The device is also configurable. When you get it, by default, it'll record everything from the CAN bus, but you'll probably not want that because that generates a lot of data. So you can set up CAN ID filters, you can set up compression, but you can do a lot more. You can set up triggers to start and stop logging based on signal thresholds. You can encrypt the data to ensure that nobody can read the data and nobody can manipulate with the data. And it's a ton of other things in the configuration. And finally, the device is interoperable, and we'll get back to this in the software section. But essentially, we want to make it easy for you to get the data into whatever tool and into whatever format that you want for your analysis. We do not try to dictate how you work with the data, but rather provide you with the tools to make it easy to get it to work in the way you prefer. The same goes for the different subtools, such as configuration files. We use open source and standardized concepts, and many of our software tools are also open source and standardized. We get this question quite a lot, so I've included it here. Now, let's say you put a CANedge 1 into a truck and you start recording all of the data. And let's say the driver of this truck happens to drive 24/7. How much data can you record? And you can see it here on the left, assuming, let's say, 700 frames per second on this CAN bus channel. That will give you 50 megabytes per hour. And on an 8 gigabyte SD card, that means you can record 7 days of data if you are recording 24/7. Now, when the SD card is full, what the device will do is that it'll delete the oldest data to make room for new data. That is what we call cyclic logging, and that is the default behavior. Of course, you can upgrade the SD card to a 32 gigabyte SD card, and then you have a month in terms of a rolling window of data. But that's not necessarily enough, and that is why in more realistic configurations where you are deploying these units for long-term logging, you may find that some of the CAN IDs are irrelevant. Some of the CAN IDs you don't want to record, at 1,000 hertz. Maybe you only want to record this particular CAN ID every 20 milliseconds and this one every 500 milliseconds. Maybe you want to compress the data and other things. If you start applying some of these functionalities in the configuration file, you can get multiple years of data recorded on a single SD card with the device. This, in turn, makes the CANedge 1 an ideal black box, as we call it, for any automotive application, but also beyond in industrial machinery and other use cases. And that is how many of our engineering customers use it. They might have an intermittent issue that happens every 1 or 3 months in their very expensive mobile crane or excavator. That's the case here with JCB. And they might send a unit into the field for the client to deploy. And when the issue happens, they now have data surrounding the event. You might also have OEMs that deploy a CANedge 1 with every single vehicle they deploy in the field, so as part of their production batch. And that gives them the opportunity to always look back if there is a warranty dispute or any similar issue. They have the data surrounding that particular event and can take the discussion based on proper terms instead of, he said, she said. Now, of course, an offline data logger has limitations. Now, let's just say you want to collect data very frequently, you want to collect it remotely, or maybe you just want to collect it at a very large scale, like hundreds of devices or thousands of devices. You're not going to send an engineer into the field across 1,000 CANedge 1 units every week to collect the data from the SD card. That's not how the world works. But you might set up the CANedge 2 to connect to Wi-Fi routers and automatically offload this data to your own server autonomously. And that's essentially the goal of our connected devices. The CANedge 2 works like this. You set up your own server for receiving the data. And here we use an interface called S3. It's a bit like FTP servers that some of you may be more familiar with, but just the modern equivalent of that. You can use a cloud server, and for many use cases, that will be the simplest to set up. We, for example, provide guides for setting up an AVS S3 bucket in less than 2 minutes through some automation. But you can also self-host your own server if you prefer a local setup, for example, in a warehouse, or if you just prefer that you own everything so that no data leaves, for example, the EU for GDPR reasons. Once you have set up your server, then you specify or you select a Wi-Fi access point. The CANedge requires a Wi-Fi router, and it could be a stationary Wi-Fi router, maybe in a building, but it could also be your iPhone or it could be some other mobile access point. You then configure the device with the details on your server and your Wi-Fi access point. And now what will happen is that the device will record the data to the SD card. And if it has connectivity to the Wi-Fi router and the server, it will automatically offload the files that are ready on the SD card to your server. You don't have to do anything. And when a file is successfully uploaded, it is deleted from the SD card. So this happens automatically and is ideal for both stationary use cases. Here on the left, you can see an example, but also for what we call periodic offloading. It could be AGVs or forklifts in a warehouse that go in and out of Wi-Fi range. Here, the device will try to upload data when it is in range. And if it goes out of range, that's expected behavior. It will then retry when it gets back into range. And the same goes for a truck that visits a specific Wi-Fi router every 2 or 3 days, for example. However, you might not have a Wi-Fi router. You might need to deploy a CAN logger across a mobile asset. It could be a car or a vehicle or a boat that is moving around the country and never gets within range of a stationary Wi-Fi router. And for such a use case, it is, in our opinion, better to offload the data via cellular, so 3G or 4G. For this purpose, we introduced the CANedge 3 this year. It is equivalent to the CANedge 2, but it has cellular connectivity instead of Wi-Fi connectivity. That is the main difference. And as you can see from this illustration here, the server concept is the same. You set up an S3 server for receiving the data, and you can mix and match, CANedge 2 and CANedge 3 device data on these without issues. Then you insert your SIM card, like a physical micro SIM card, on the back of the CANedge 3. And again, you configure the device with your details. When you do this, that will essentially allow the device to connect to your server and upload the data. You can see it illustrated here. So if you have a car, what will happen is that every time a new log file is ready on the SD card, it is immediately uploaded through cellular to your server. And you control the frequency. It could be every 50 megabytes, every 1 megabyte, every 1 hour, or every 10 seconds. That is up to you and can be configured and can be changed over the air. It's also ideal for use cases like maritime vessels, where you're moving in and out of range or in and out of cellular coverage. When you're within coverage, the data is offloaded. When you're far from shore and out of coverage, data is accumulated on the SD card. Something that is a bit special about our use case is that we are not having many customers that are recording only 100 megabytes per device per month. Most of our users will be recording 5 gigabytes, or let's say 1 to 20 gigabyte per device per month. And this would normally entail that cellular data transfer would be prohibitively expensive. Some of you might have good company agreements on SIM cards or may be able to source low-cost SIM cards in your own country. And for such use cases, you can use those perfectly fine. The CANedge 3 is global and supports practically all SIM cards, with a few exceptions like Verizon in the US. But we also know that, again, in the US, if you are going to have a roaming SIM card and you're going to deploy this across multiple units, the price of this would normally be $50 per gigabyte for most use cases. And at 10 gigabytes, that's $500 per device per month. That is a bit much. Of course, you can reduce your file size, as we discussed earlier, but for some use cases, you may want to transfer quite a lot of data. So to solve this, we essentially partnered up with a company called Core that has a SIM card called SuperSIM. And this we include free of charge with every device. The way it works with this one is that you can optionally use it. You create your own account. So CSS is, again, not involved in any way with your data or your subscriptions, anything. We are out of the loop. We just happen to have negotiated a good price on this SIM card, which is basically in the US, as an example, $5 per gigabyte instead of 50. So it's 90% lower in terms of pricing compared to what you would usually receive. And it doesn't matter whether you use one SIM card or 1,000 SIM cards, because the discount is based on our company's volume, not your individual volume. You can read more about this on our product page. The CANedge 2 and the CANedge 3 are used in, I would say, very diverse use cases. Whether it is simply for automating the data transfer, as in the case of Volkswagen, for example, here to save costs, or whether it is to do in-field telematics like Grafana does, there are many different usages. Some of the more sophisticated ones are things like what Andrew Miller does on the right, who basically creates a near real-time mobile app using data from the CANedge 3 that allows farmers in operation to more efficiently pick bales from the field. Another specialized use case is an OEM that uses more than 300 CANedge 2 devices in warehouses to do predictive maintenance across automated forklifts. So you can do pretty much anything with the devices. Something new we also introduced this year is the ability to get your CANedge with internal GPS and IMU. We did this because we found that the CAN mod GPS, which was a separate GPS module, was a very popular add-on for our devices. Now we have this integrated into the device without increasing the form factor, which is pretty cool. What is also cool is that you get quite a lot of data. It's not just GPS position, because this is both a GPS and an IMU. You get a lot of signals, and I'll show some of them in a minute. You also get high precision through something called sensor fusion in automotive applications, and you get high frequency with 5 Hz on all of the signals. This is useful for many use cases, both for enriching your data sets, but also for doing things like synchronizing your real-time clock in the device to keep a fleet of devices in full sync in terms of their timestamps. And you can also use it for some very nice use cases like controlling your logging of data and controlling your transmissions of data via something or some of the internal signals. I use this in my own car to say I only want to send requests into the car when the speed of the vehicle is not 0. And this ensures that I'm not draining the battery of the car when the device is continuously powered and the car is turned off. There are many use cases for this. You get the position, of course, through the internal GPS. You get the speed based on the GPS, which is very useful to have across all applications. You get the trip distance, you get the altitude, you get the ability to set up geofences that are then output through the CAN frames. You get the high precision GPS time, and you get acceleration data. And due to the sensor fusion, you can even get attitude like roll and pitch and yaw for automotive applications. If you need more data than this, you can connect some of our sensor modules like our thermocouple to CAN or our CAN mod input for analog and digital and pulse sensors. These can be connected on the second port of a CANedge and will allow you to collect additional signals in perfect time synchronization with the stuff you're recording through the first channel. This is a common way of utilizing the fact that all of the CANedge devices have two CAN channels. So that was the hardware. And before we stop here, I'll go through the software tools. And we have two categories of these for the CANedge. We have what we call device configuration and management, and then we have data processing and visualization. And I think the data processing and visualization will also give you a bit of context on how these DBC files fit into the mix and how you actually get to the actual interesting data from your raw CAN bus data. If we start with the first category, when you get the device from us, the first thing you typically do is to configure it. You take out the SD card, put it into your PC, open up your browser and go to our configuration editor. And then you open the JSON configuration file here, and it'll show you a menu like the one you see on the screen. And this is where you can, in a nice GUI-friendly way, configure every detail of the device: filters, log file size, real-time clock settings, and other things. This is also where you input the server details and the SIM or Wi-Fi details for the CANedge 2 and 3. Now, let's assume you have a CANedge 2 or CANedge 3 that is now connected to your server. Typically, the way you want to manage the devices is now remotely, because these devices will be operating in vehicles or machinery that is perhaps hundreds or thousands of kilometers away from you. So you need a simple way to keep track of how are these devices performing, what does the data look like that they have uploaded to your server, and what does, for example, the meta information look like in terms of how much data is left on the SD card, when did each device last connect to the server, stuff like that. All of this can be done through CAN Cloud, which is essentially like an IoT cockpit tool. It doesn't do any data visualization. This purely allows you to log into your own S3 server and manage your devices, get your data, and also perform over-the-air configuration updates. So let's say you have a device in the field where you now want to change the filters because you figured out that you are recording a bit too much data. So you want to reduce it a bit. You just go into CAN Cloud, select the device, change your settings, and submit the new configuration file, and the device will then update itself. If you want to get a more basic way to access the data on your S3 bucket, you can also mount it as a local drive. So I use this all the time, where essentially all of the data from your CANedge 2 or CANedge 3 devices will be accessible as if it was stored locally on your disk. So this is very convenient, and you get all of the typical file explorer functionality through this. And now for the more visual part, we have quite a few processing tools for working with the data, and each of them serve a different purpose. And I will also be introducing a new tool today that we released yesterday. So let's start with perhaps my go-to tool on a daily basis called ASAMMDF. Whenever I need to analyze a log file from the CANedge or do a quick visualization or understand the data, whether it is the raw CAN frames, the raw LIN bus frames, or maybe it's, where was this device located when something happened, I use ASAMMDF. It's a GUI tool for Windows and Linux. It allows you to load the raw data from the CANedge directly. You can then load your DBC files and decode the data to physical values, essentially creating a new file that contains all of the decoded information. And as you can see on this screenshot here, that allows you to do quick visualizations and also to do geographical plots if you have GPS data, and even time synchronize the two. This is extremely useful for general purpose use cases and is great for working with a single log file. However, we also have many users, in particular amongst the automotive OEM engineers, that are familiar with other tools than ours, and that's okay. It might be vector tools, it might be peak tools, two of our German competitors, or maybe not competitors, but two other companies in Germany that do similar tools. And here we make it very easy to get your data from the CANedge into a compatible format so that it can be loaded in these other tools. Essentially, what happens here is that you take a log file from the CANedge, you drag and drop it if you're on Windows or you use the command line, and then you create a copy of the file in the format that you select. It could be CSV, it could be vector ASCII, peak, trace, or something else. The result is essentially, if you take the CSV example, a small file that you can open in the text editor that has the timestamps, bus channel, CAN ID, data bytes, etc. So this is great if you just need to work with the raw data, or if you need to load the data into a tool you're more familiar with. Then these are very useful for that. But as something new, we wanted to also have the ability with similar functionality to perform very quick DBC decoding of the data. SRMDF that I mentioned before is great, but it is a GUI tool and it takes a bit to load, and it's a few clicks to essentially DBC decode your data. And it's mainly useful, in my opinion, for file by file analysis. You may have a single trip, you want to analyze, that's great, but what do you do if you have more files? Then we have these new tools here, and I'll explain in a minute why they are really cool. If you just take the most simple version of it, the MDF to CSV underscore decode, very easy name. What this allows you to do is to drag and drop a file once you have put the relevant DBC file next to the converter, and it will create again a CSV file just like before, but now you have the decoded information available. In this particular case, you have a message that contains speed and some information regarding the speed parameter. This is very easy because you just drag and drop the file, and you could drag and drop an entire folder of files or entire folder of devices containing files, and then it would essentially DBC decode all of it and put it into a nice timestamped structure. But CSV files, as you may know, are not very efficient to work with. So we also created something called a Parquet file converter. So what this does is essentially the same thing, but instead of creating CSV files with the output, it creates Parquet files. And this is where the magic happens, in my opinion, because Parquet files allow you to create what we refer to as a Parquet data lake. Essentially a Parquet data lake that consists of DBC decoded data. And why is this cool? It's cool because you can store this data lake locally or on S3. You can have essentially a ton of data in here, and you can easily automate the creation of this data lake, in particular if you are within AVS, for example, which most of our CANedge 2 and CANedge 3 customers are. Parquet files have great support in Python and MATLAB, and they are ideally suited for out-of-memory operations. And if you have a couple of devices and have worked with the CANedge, you'll know that you quickly hit the memory limits, because you're not, again, recording a single gigabyte of data. You might be recording terabytes of data that you need to work with. And if some of you have tried to process terabytes of data from, let's say just 50 or 100 CANedge units, you will know that it has previously been a bit of a challenge, to put it mildly. What this does is essentially providing a way to solve that challenge. And Parquet data lakes are the de facto standard. Just like CAN bus is the standard communication framework or methodology within vehicles and industrial machinery, Parquet data lakes are the equivalent when it comes to big data. And in our opinion, it is a trending way of storing, terabytes of information in a structured way that is low cost, but has wide support. And when I say wide support, I'm meaning really wide support. If you take the MF4 format, you have tools like SRMDF and other tools, vector tools and the like, that support MF4 files. But you have 100 times more tools and softwares and APIs that support Parquet data lakes. So this is really a way to be able to work with the data from the CANedge in the way you prefer and in the tools that you want. An example of this is MATLAB, which many of you might be familiar with. Previously, we relied heavily on the ability of MATLAB to load MF4 data directly from the CANedge through something called the Vehicle Network Toolbox. And you can still do that perfectly fine. And that's great if you're going to work with a single file in MATLAB. But if you want to, process 50 gigabytes of data to extract some insights, it's not so great. But you can have a Parquet data lake that is stored locally on your disk, or it can be stored on S3, whether it is Minio S3, AVS S3, or something else. And with a very few lines of code, you can essentially get MATLAB to load the data into something called tall arrays and do any type of processing you want and create very advanced statistical analysis with minimal effort because it is a standardized format to store the data in. And all the heavy lifting is done by the MF4 decoders that I mentioned before. So this is really cool. And the same goes for Python. Just like MATLAB, Python has wide support for Parquet files and Parquet data lakes. That means you can still load the data from the CANedge through your MF4 files directly using our Python API, and that might be preferable for some use cases. But if you want to process data at scale with Python from the CANedge or from many CANedge units in a seamless way, where you can ignore whether it is from log file A or B or what time period it is from, then this is the way to do it. And for both MATLAB and Python, we provide some basic script examples to get you started in the new MF4 decoder documentation. And finally, many of our users have started using dashboards to visualize the data from the CANedge. And I understand why. It's a very nice way of creating, you can say, a static view of particular set of signals that you are interested in, maybe for internal sharing within your engineering team, maybe to show off to your manager, or maybe to share dashboards with your clients to be able to review diagnostic events together, or in order to, as a system integrator, perhaps sell services that are based on top of the CANedge as a hardware platform. For such use cases, Grafana dashboards are great. And Grafana is an open source tool. It can do a ton of things, and we make it very easy to do the necessary things in order to get started. That means we provide dashboard templates and step-by-step guides on how to set this up. So we've had dashboards for quite a while, and we've had many different ways of integrating with the dashboards. But now that we have the new Parquet data lake approach, we also decided to use this as our new recommended dashboard integration. And the way it looks is this. Essentially, what you can do now is to have a CANedge, it could be a CANedge 2 or a CANedge 3, that is connected to an S3 bucket on AVS. And as log files are coming in to AVS into your input bucket, they will be automatically DBC decoded using something called lambda functions and using these new MF4 decoders. The resulting Parquet data lake will be stored automatically in a separate bucket over here, still within the AVS S3 environment. And then something a bit magical happens over here called Amazon Athena. This is a tool by AVS that allows you to query data from a very big Parquet data lake that is stored in an S3 bucket. And when I say query data, I mean query it super fast. So it uses parallel processing and a lot of nice and nifty tricks that would never be possible to implement outside of this environment in order to allow you to return data from gigabytes of data in seconds. And Grafana natively integrates with Athena, making it very easy to create powerful dashboards. And the very nice thing about this is you have all of this set up in your AVS account. And if you don't have a CANedge 2 or CANedge 3, you can have a CANedge 1. You just create an AVS account for this purpose, and you can do the exact same thing, just uploading the data manually and still have the same workflow here. The reason we switched to this as our new method of integration is that it solves one of the primary pain points we had with the previous integration, and which I also believe is the primary pain point for any similar device to ours that tries to write data to a database. A database is a way of storing DBC decoded data in a very hot and fast way. It allows you to access the data swiftly. But this comes at a cost. To store data in a database such as InfluxDB that we have been using in the past, you would pay a lot of money. And when I say a lot of money, I mean maybe $150 for 100 gigabytes of storage per month. And that's not an unrealistic size or volume to have for a single device that you might want to be able to visualize. So you can imagine that if you're going to pay $150 for having this dashboard integration per device per month, you're not going to do it. So we wanted to solve this. With the new Grafana Athena integration, in our opinion, it provides similar functionality, similar speed. It's easier to deploy. It's easier to maintain. It's similar in terms of how many users can access the data at the same time. It avoids many of the scalability bottlenecks that the influx integration had. It allows you to get access to all of your data, so you can get thousands of signals if you want, where InfluxDB is limited to 200 signals. But the best part is that it is 95% lower cost compared to storing the same equivalent amount of data in Influx. And that alone, in my opinion, means that this is the integration that we will be promoting because our users, they log a lot of data. So that was pretty much what I wanted to share in terms of our hardware and software. We only have 4 minutes left, but let me try and go through a bit of Q&A still, and I'll try and answer some of the questions that have come up here in the chat. And you're welcome to ask more questions, and I'll try and see if I can cover some of it. So let me see if something has come up. So I have a question here whether you can use a device like the CANedge or our other data loggers to essentially create algorithms which can control the sound parameters for a vehicle alerting system. And this is a good example of something that is not a good use case for the CANedge, in my opinion. Our devices are great at recording data, and you can transmit data as well into the CAN bus, but they are not perfect if you're going to do, you can say, very customized control as in this use case. Let me see if there are some other examples here. So here is another example where they are asking which device is best suitable to decode electric vehicle CAN bus data in order to get information like state of health. And I get this a lot. There is not a specific device that is better or worse for recording electric vehicle data. You can do this with any of our CANedge devices and pretty much with most CAN loggers on the market. The key is just that you're able to get access to the raw CAN bus data. The trick is, even if you get access to the raw CAN bus data, you will need to be able to decode it. And within the electric vehicle area, there you can say it becomes more complex because it typically involves multi-frame communication. The CANedge is probably what I would recommend here, but whether it's a CANedge 1, 2, or 3 doesn't matter. But I would recommend to go to our case studies section because we actually have case studies for the most popular electric vehicles, including the Hyundai and Kia brands, all of the Volkswagen brands, the Tesla brands, and more. So you can find basically details on how would you record data from these particular types of vehicles. Another question is whether we have an adapter for Ethernet connection, and we don't today. What we are looking to potentially create is a CANedge 2 Ethernet, where instead of basically transferring the data through Wi-Fi to your own server, you would connect an Ethernet cable to do a wired connection for the data transfer, which is useful in cases where Wi-Fi coverage is not an option. I don't have a timeline, but it is something that is considered on our roadmap. Another question is about the SD cards and if they are normal. No, they are not. The SD card used in the CANedge is unique. It is a specific SanDisk SD card, industrial type, and even other industrial SD cards would not necessarily work because these SD cards are very fast. And they need to be fast because if you cut the power to the CANedge, it needs to safely store the data on the SD card without losing or corrupting the data. And luckily, these SD cards enable us to do this within our hardware. Otherwise, the hardware would probably be 20% larger. But it also means that you cannot use third-party SD cards in the device. Then there is a question on whether this session will be available. And yes, it will be available immediately on YouTube after this live stream here. And I think there are some questions on the software connection. I think those are covered. There is a question on the IP rating of the CANedge 3, and the device is IP40. That's the case of all of the devices. And that means that if you're deploying these in areas where you have, for example, wet or high humidity, or you have a lot of dust, you will need to shield them somehow. We are hopefully at some point adding a customized box for allowing IP65 or IP67 rating. But until then, that is something you will have to solve on your own side. There is a question on whether you can get the data directly without a software or server. And I think we covered perhaps that on the server side and on the software side. So there are many different ways you can extract the data. At the end of the day, for all of the devices, you don't have to use a server. They can work offline, whether it is the CANedge 1, 2, or 3. So if you don't provide a server, it will just accumulate the data on the SD card, and you can always take it out. If you're looking for a demo, as one of the persons in the chat is doing, of the software and tools, then definitely go to our website, find the docs section, and go to the intro. And in the intro, you will find our process section, which explains all of the software tools I mentioned here. And since all our software tools are free, you can just download them. And we also provide sample log files and sample DBC files. So you can try the entire workflow without buying any devices, so you get a feel for how it works. Let me just see. There are some questions on whether data can be extracted in real time, and I think go to our case study section and check out, for example, the bale drop. It's one of the featured case studies with like John Deere tractors on it. That is an example of a user that has managed to do essentially near real-time transfer by transferring a log file every 10 seconds. Another featured case study uses a 30-second split time to perform predictive maintenance. So yes, you can set this up to get data into your server, use Lambda functions, which we provide automatic deployment of, and then get the data into whatever platform, whatever database, or whatever system is required to, for example, use it in an app or other application. I would not say this is our primary use case, and I would also say it requires that you have the technical expertise to execute this, but we do provide pretty much all of the toolbox tools to get it done. Then there is a question on whether you can configure the logger to let it send a service like software version of the ECU to have this info in the same log. And I think if I understand this question correctly, then to some extent, yes. So an example of this is that you might set up a transmit message or a sequence of transmit messages that the device will fire after a power cycle. That means that when you insert it into, let's say, a new car, for example, you could request the vehicle identification number or some other information like a software version of an ECU. So as long as you know what requests to send, then it can transmit these requests. It will log the responses, and then you can essentially decode the information as part of your post-processing. Then there is a question on whether this supports extended frames and CANFD, and yes, it supports CAN, both 11-bit and 29-bit CAN IDs, and it supports CANFD as well with bitrate switching. And there is a question on whether DBC files work with extended frames, and again, if we're talking extended CAN ID frames, then yes, they do. And maybe the question is different, but I think in that case, go read the documentation or send us a question by email, then we'll cover it. Then there is a question on a bit back and forth. Yeah, there's a question on whether we plan to integrate MQTT into the CANedge 2 or 3. So MQTT is a protocol we originally considered, and it's a very popular protocol for small-scale data transfer. The CANedge can in some cases record several thousands of CAN frames on multiple CAN channels at the same time as it's recording internal GPS and IMU data. What that translates into, and this is in particular if you're recording CANFD data, is a large accumulation of data per minute. So in the most extreme cases, you might look at 5 megabytes per minute in a log file. And 5 megabytes per minute is not something that is very suitable for transferring to a remote server via MQTT. That was at least what our research showed, which is why we use the S3 interface instead, as it is better suited for this particular use case. Again, a question on whether we plan to have real-time data transfer. And yes, we would like to have remote real-time streaming potentially in the future. We do have some considered plans for this, but it is not on our short-term roadmap. So again, follow our newsletter, follow us on LinkedIn to get updates on this. Then let's just see. Yeah, there was a question on, again, the CAN transport protocol, whether that is supported. And yes, you can use the CANedge to record both responses that are according to the transport protocol. So this is what I referred to earlier as multi-frame data. And our tools and software decoding tools do support multi-frame data as well. And this is also something that can be set up to be supported in the DBC files. For details on this, see our documentation. Then there is a question on what is available on the internal CAN bus of the CANedge 2. And if you have a CANedge 1, 2, or 3 with internal GPS and IMU, then this data from the internal sensors will be available on what we call the internal CAN bus. So this is a pseudo CAN bus which records the sensor data. And it's nice because it allows you to decode this data using DBC files, just like all of your other data. Then there is a request on whether we can retrieve manufacturer references of the ECUs on board a vehicle using OBD or UDS. And my answer is, I am not sure. You probably can, but if you're asking the question, then you probably don't have the information to do it. You will probably need OEM proprietary information to do it in most cases, would be my expectation. Then there is a question on the CANedge 2 speed in terms of what the upload speed is. The CANedge 2, under ideal circumstances, uploads with 0.3 to 0.5 megabytes per second. As I mentioned before, the accumulation rate is 5 megabytes per minute as the maximum accumulation rate in any practical use case, and typically you're looking at 0.2 megabytes per minute of accumulation rate. So in other words, you typically have 60 times faster upload speed than you have accumulation of data, meaning that it is going to be sufficient to keep your SD card offloaded if you have relatively frequent connectivity to your Wi-Fi router. Then there is a question on WWH OBD, which is a specific OBD protocol, and we covered this in our UDS intro, so I recommend to see that, where we also explain the how to decode it, and we have a DBC file for it, so send us a message through our contact form. Then there is a question on whether there will be smaller versions of the CAN bus data logger in the future for more weight-sensitive applications, and how durable the logger is. And I think on the durability, again, see our case study section, you will see that it's used in some quite extreme environments. So we consider it highly durable. I don't think it's possible to create a smaller CAN bus data logger with the same specs. I would claim that we have the best spec to size ratio in the world, but you could create a smaller data logger with, you can say, worse specs. I'm not sure that is something that we will do in the near future. Then you have the question on whether it's possible to configure a CANedge to start logging based on certain conditions, and the answer is yes. That is called a control signal or a trigger. So, for example, when engine speed exceeds a certain value, start logging. When it goes below another value, stop logging. That is a core configuration option. Then there is a question on the data formats, and the device stores the data always in the MDF file format, which is a popular standard within the automotive industry and supported by various tools. But as mentioned earlier, we also provide many software tools for easily getting this data into other formats. Then there is a question on whether you can connect the CANedge to the XCP protocol, whether it supports seed and key, and if yes, where to find the docs. And the answer is yes and no. You are able to do very basic CCP and XCP polling requests. And this is a bit like OBD2 and UDS to those of you that do not know. This is perhaps just a bit more of an advanced and niche protocol in comparison. But the device does not support seed and key authentication, which is essentially a bit like exchanging a password with the ECUs on the CAN bus. So for that purpose, you will need, for example, a vector data logger or something similar. It is not something we support today. But if you're interested in this topic, we of course have an intro to CCP and XCP, and you will find it in our guide section. Then there is a question on whether you can integrate webcam video along with CAN data. And the answer is you probably can, but I am not sure CAN bus is ideally suited for storing high resolution webcam data. For that, you'll probably use another protocol. And let's see. Then there is a question, if you're graduating in 6 months and want to get into the automotive electronics industry, what would you suggest that I learn? And I think a good place to start is, again, our guide section and go through all of the intros to the different CAN protocols. They go into far more depth than I have been able to do in this webinar. So that's a good place to get started. And there is a question again on the XCP and CCP logging, and it's whether the CANedge supports something called A2L files, which is a bit similar to DBC files we mentioned before, and which also describe how you communicate with ECUs that support this protocol. And the answer is no. Again, this is, you can say, an area where the CANedge is deliberately focused on a subset of the potential use cases, with something like XCP and CCP being a, you could say, more advanced use case than what we originally have designed the CANedge for, and not one we encounter very often. So again, there are tools on the market, for example, from Vector. They typically cost 5 to 10 times more than a CANedge, but they will allow you to record this, and they will support A2L files. Then there is a question on how we can send vehicle-specific requests using a CL2000, which is one of our other data loggers, to get expected responses without recording all of the data. And for this purpose, you can set up CANID filters on the CL2000. They are more basic than on the CANedge, but you can still do it to some extent. And then there is a question on whether we will provide a solution for triggering based on signal value changes, like doing a custom external action. And if not, what would you recommend? And I would say for this question, it would most likely be supported within our existing control signal configuration options. Try and read through the documentation in our docs page. And if that in doubt, then send us an email with details on the question. And then there's one, Ben Martins, who likes our online guides, and I'm very happy for that. There is a question. I think that was actually the last question that I can see in the overview. So in the interest of not dragging this out too much, I will shut it down. But to end this, I will just say thanks for joining us. And you can always send us an email through our contact form. And you can also follow us on LinkedIn for future updates, both in terms of, you can say, Canvas intros and the like, but also in terms of future webinars. I will most likely be doing one in not too long on the Parquet data lake aspect and the new dashboard integration. I think that's pretty much it. Thank you for joining, and have a great day.